Hey guys, welcome back again. So let's try to solve today's questions. Okay, let's start with the LeetCode. Minimum elements after replacement with digit 7. What's the meaning? You are given an array nums. You replace each element in nums with the sum of its digits. Then the minimum element return the minimum element in the nums after all the replacements. So, for example, it is like 1 and okay. So, okay. So there will be one function which just converts a num to a single digit. Okay. So let's see in digit. Uh, Here we pass num. So let's say this is result while num is greater than 0. Then digit num modulo 10. Okay, and this the plus equal to digit num divided by equal to 10. Okay, that will be the so for in nums here we will have the minimum element. In fact, let's put num of 0 and okay. Okay, let's see if the min element will be balanced or min of min element or the digit sum of return min element. Okay, let's try to submit. So it's accepted. Now let's see the GFG today's question. Let's count the sorted digit groups. What is this meaning? A string S consisting of digits. You can split continuous parts, substrings. For example, string 112 can be split as 111. 112, 112, 112, and again 112. The grouping is considered valid if sum of digits of the subgroups form a non-decreasing sequence from left to right. Determine the total number of such valid groups for the given string. So you can see 1, 1, 1, and 9. So one valid group here mentioned, you can put it like this. Okay, These are the valid ones. 1 and then 1 9, 1 1 and then 1 9, then 1 1 1 and then 9, then 1 1 and 1 9, then again, then again. Okay, okay. Now need to understand how we can get these things. Okay, so and this length is, not, it's smaller, not some sort of. So we can, let me think how we can solve this question. So since it's a substring, we can check all the valid substrings. Okay, so how we can do that? All the valid. Hmm. Let's see the example properly. What is this? 1119. Okay, so first we can convert, I guess, to the array of characters. Okay, once we have this, the array of characters. Okay, now let's check. So let me think now how we can do this. One thing for sure that we need continuous part. Okay, so is this valid itself? Okay, uh, let's try some sort of in DB way. Okay, yeah, in itself, is it valid? For that, we have to make sure for everything, right side should be greater than or equal to this, right? And okay, let me again see. Group, the group itself should be uh, sum of the digits, and if the sum of digits of subgroup form the non-decreasing sequence from left to right. Okay, so when we form a group, then the sum of the group should be like in non-decreasing order. So that is what it says. Okay, so let's say we form this a group. Okay, then the value of this is 1, and again when we form this group, this value become 1 1 and then 9. Let's see when we form a group of these two, then it will be like 2 1 9. Okay, which is again wrong, so we have to put this one into one sequence, so that is 19 and 2. Okay, so things that we want is when we form group, okay, we have to calculate uh, the sum of digit. We know the code of sum of digit, right? Just we need to form the groups now. That is the question, divided groups. So how to create groups? So one thing I'm able to see is we can do like some sort of partition, okay, and every partition will check their sum, okay. If it's greater than if it's less than previous, okay, previous becomes greater than current, then this current one is invalid, okay. Some sort of, okay. So how to we can calculate, let's say we have for loop, okay, which covers all these, okay. Instead of saying for loop, I can say like we'll start solve function, okay, with passing this index, okay, and we'll pass the character array also, and this index shows, so we need to know the group size, right, and then we can figure out. But let's see, then we form, start a loop from I is equal to index, okay, index I should be less than the ARR of length, okay, I plus plus. Now once we have this, now let's say we pass 0 in this, then it will start uh, partitioning to 0, I guess, okay. We can have first substring from this index to this index, this index to this, meaning that we have, let's say, group from from this area of index to this particular item, this, then for now let's say this 0, this 0, we can have like I plus 1, okay. So first we will have this, then we calculate the sum of it, okay. When we calculate the sum, okay, and okay, let's say we calculated the sum also, this groups, okay, uh, get digit sum, let's say we pass this loop into it. When we have sum, then we have to check for valid, right? For that we must know the previous sum, right? So we can have one more item into this, okay, which is previous sum. Now, now one thing we can do, if current sum is greater than equal to previous, then it's valid. So try to solve for next, okay. From this index, since it's considered, right? So this one is considered index values. So let's go for I plus 1, yes, and the array, and previous will be our current sum now, okay. And if it's invalid, then we actually don't need, since we need the number of different partitions, right? Which gives this goal. So we need to return integers values, right? So let's say count. Right now there are 0 ways from this. Okay, okay. Let me understand again. So we can have uh, this count here. Okay, C and D plus equal to, and there is one more. When we reach the last index, meaning that we able to partition properly, if index is greater than equal to arr dot length, then return 1. Okay. Now at last we will return our current count. Okay, so that is what I'm able to think of right now. So let's try to try them. Okay, first we will add 1. Okay, first we will add 1, then the current sum is 1 self, right? Then we go for the next call. Okay, since the previous for this is 0 initially, so when we go for the next call, then it again picked 1, and the previous sum is this 1, which is again good. We go next, and then we go 9, and yeah, then we out of we reach out of, then this will return 1. This will return, this one, this returns 1, and which it counts, and then it again returns 1. It counts, but then it becomes this much stuff as a substring, and again calls. Okay, then again it returns 1, meaning there are 2 at this point. So it will return 2. It stores 2, but it assumes that, let's say, if I am this much size, okay, then it goes for this, then passing the previous sum 2, then it says it's invalid, then it goes for this, then it becomes 90, which is good. Now again one call which returns 1, and then this again returns 1, which becomes 3. So seems like it will work. Okay, let's try string s. Then instead of string, let's put string s or not. Then we will have the index, right, in IDX. Then we have in previous if IDX is greater than equal to s, then return 1. Otherwise, or a is equal to IDX. A is less than s dot rank. Okay, that plus k. Then we can have a group right first. Then group. Okay, so and this group will be s dot string uh, idx to k plus 1, right? And we need the digit sum, right? But one thing I'm not able to get is we can directly calculate it. Okay, we will have like run so some value, let's say currently 0, then s dot can and k, you know, can and k will be added to this value. Okay, so current group sum plus equal to s dot characters value. Since we know these characters are there, we can minus this 0 from it to get the number. Okay, and we can add this the current group sum. If this current group sum is greater than equal to previous sum, meaning it's a valid one, and we will have the count also, which is initially 0, and then count plus equal to solve s a plus 1 and previous, previous one will be now the current group sum. Okay, once we have this, at last return our count and return solve as idx, let's say 0, and previous sum is 0, that's it. Okay, so since we have only positive numbers, then we can have the 0 initial. Okay, let's try to run this. Run group sum p sum. Okay, this should be previous sum, and this is current group sum. Okay, now it is valid. Let's try another example. 1, 2. We need to find edge cases also. 1, 2 is working, and the length is we can have only one length, which is let's say 2. Okay, it's working. So should we add TP into it? Since it's there is only one index as a variable. Also, okay, let's try to serve it, and if it fails time complexity, then we can improve it. So see, time exceeded, and let's implement the TP stuff here. Okay, so how to get it? Mm, we have previous sum and then uh, idx. So 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 how to improve time complexity? Mm, we can we can have one thing if current sum no, actually we have to think more. So there are two variables that those are changed. First the index and then previous sum, right? So, so what, since the length is 100 only, the character length, if we avoid using previous sum and use the dp instead, okay, then probably uh, then it will work, I guess. So so let's take extreme case. At, I'm thinking let's put the previous sum for now. And let's say extreme case, every character is 9999. Okay, then it will be like 100 cross 9, meaning 900, right? So in dp of new in first will have the length, you know, which will be this. And for previous sum, we have extreme the 999, right? Meaning 901. Okay, and we can pass dp. So dp, then here we need also pass dp. Okay, and here we can check if dp of idx and previous one is not equal to -1. So then return dp of idx and previous sum. Okay, and otherwise we can update this here. Okay, let's try to run it. What is this? Previous sum. And again we need to put -1, right? So for n so dp arrays in so -1. Okay, and we need extreme case, right? So this put 9999999, and let's try to run it. Okay, it's passed. So we, if you watched this part, try to optimize this one also. Okay, so yeah, thank you for watching.